Thanks, Matt. Evening, everybody. So this is a listing from DB Engines. This is the top 20 database engines. This is this month, actually. Anybody? This is the top 20 database engines. Anyone using at least one of these? How about at least 3? At least 6 or more? Adventurous. So they're not in any particular order or grouping here, but if we were to group them by, say, relational versus non-relational, it might look a bit like this. And as you can see, really 13 out of the 20, or 65%, are relational database management systems. Now, here we're not really looking at the total points accrued by each one. If we were to do that, and not just the top 20, but across all of their databases, it'd look a bit more like this, where relational databases are taking about 80%, followed by document stores at 6.5%, and then search engines and key value stores at about 3.5 each. Now, the point of this is not to say that one of these is better than the other. These are all really great database engines that will work well when used for the appropriate use case. The point here is just to say that relational database management systems are, today, incredibly popular, and they will continue to be incredibly popular for the near future. Some of the features they offer, like transactions for certain applications, are, in fact, really important. Now, for your front-end devs, they could care less. Right? Your front-end devs just want JSON, and they typically want it tucked behind a nice, fancy, RESTful API. Right? So what we're going to do today is look at how you can convert between the two. Really just going from relational to JSON. We don't have enough time in a lightning talk to do it the other way as well. But here we have a typical, well, this is the HR schema in Oracle database. So this is one of several sample schemas that are included with the database to help folks learn. There's others like for data warehousing and whatnot. But it's fairly straightforward. You have an employees table. You see that employees have a department ID, which points to the departments table. Departments have a manager, which points back to employees. And of course, departments have a location, which have a country, which have a region. And then we have jobs and job history recorded as well. So when you think about converting this type of schema into JSON data, there's not just one way to do it. There's no one right way. You could, for example, start with employees and traverse your way down. It might look like this, where you have employees with their job history, and an employee has the department here with locations, countries, and regions. Frankly, I don't particularly like that format, so we have this one, where we start with departments. And so departments still have location, country, and region, but they also have an employees array with the other attributes going on down from there. So this is the format we'll use, and the resulting JSON from that particular schema would look like this. So we have, this is for one department, department ID 10, which is administration. You see the location property. You see manager, which is an object. You see employees, which is an array. And so what you're seeing here are objects, arrays, strings, numbers, and Booleans. This is just standard JSON, right? So the first solution I want to look at for this is actually not Node.js. We're going to look at Apex JSON. Apex JSON is a PL SQL package. For those of you that do not know what PL SQL is, that's the procedural language extensions to SQL. It's Oracle's proprietary language for running code, if, then, else, loop on the server side. So this package actually comes as part of a much larger application development framework called Apex, but we're just going to use this one little package to do some JSON conversion. Oops, got ahead of myself. To show you this, I'm going to go into SQL Developer. And I'll show you the function here. So what we have here is create a replace function, get dept apex JSON, and we're passing in a department ID. Next here, between the is and the begin, is a declaration section where we can declare variables we intend to use. And then we get into the execution section with begin. So here you see the first reference to Apex JSON, where I'm initializing it to put its output in a clob. And then we continue on down, and you see a select statement. So we go to the departments table. We pull out a record, store it in this local variable. Then I have a call to Apex JSON open object. This is where we start outputting to our clob output buffer. And then we can write properties, such as ID and name, from the record that we fetched from the table. So this is an overloaded method. If it's a number, it puts it in as a number. If it's a string, it puts it in as a string, and so on. So you can continue on down, and you go to the locations table. And then you can write out properties from there. Notice here we're opening an object before having closed the previous object. So this object becomes a property of that object, right? It's fairly straightforward. And this is already compiled. If we go down to the very end here, we finally close our employees array, we close our object, and then we make a call to get the clob output, and we can return that out to the caller. I have a little test here to show us how this runs. So here we just declare a variable, and we're looping 100 times, but really there's 27 departments in the departments table. So 100 times 27, we're doing 2,700 invocations of this function, right? And all I'm doing is calling it and assigning it to a variable which I'm not using afterward. So when I run this, it's running. All right, so it finished in 3.0 seconds. Not too shabby, right? So now that we have something to compare it to, let's take a look at how we might do the same in Node. So here, this is the first take. Our structure in the Node code is going to be very similar to what you saw in the PL SQL code. Query, work with it. Query, work with it, and so on. Of course, we're going to use the Node Oracle database driver for this to execute the queries against the database. Actually, earlier this week, thankfully, the driver got an update, and we now support Node 4.2 as well as 5.0, which is awesome. A lot of folks were complaining about that. We were only up to 0.12 prior to that. The results from the driver, they're just like a native JavaScript object, right? So not quite JSON, but we'll manipulate that object, and then we'll stringify it or serialize it, and then return it to the client. So that's the idea. So here's our solution written for Node. And so we bring in the driver, and we have a function here, getDepartment, takes in a department ID, ultimately invokes a callback. So we use the driver to get a connection to the database, and my database is just running in a local VM here. So no real network latency, but it works. And so once we have the connection, we can then use it to execute a SQL query. So this is what that looks like. Pretty straightforward. And then you see we have the ability to send in bind variables. So the value in this variable goes into this bind, and you can see it referred to here. This is the safe and performant way to execute queries on Oracle. And then we get the results, which we can then start to use to build up our department object. This is the main department object we'll build and then later serialize out to the client. So of course, one query is not enough. We then go to get location details, passing some of the things we've already collected along, and we run the next query on locations. We repeat that with countries, with employees, with jobs, employees again. And when we get to this last one, what we're doing here is we're using async because for each employee, we need to get the job history. So this will loop through that, get all the history for the employees, and at the very end, this function down here will run and then send out the stringified result in JSON format. So if we've run this, it's running, it's running. You can see the elapsed time here on the right. And if we look at just where we are at 10, right, 1/10 of the total load, we're talking about 8 seconds. So about 100, 8 times 10, we're at 80. So about 120 seconds to run, or, not great, right? Let's not let that finish. We definitely want to make that a bit more performant. So the first thing we need to do, this is take 2, is start to use a connection pool. As you saw in the code, I was just grabbing a connection, and there's some overhead in any system with creating a connection to a database, which is why connection pooling exists. The idea is that we create a pool of these connections. When we need one, we simply grab it, we use it. When we're done, we release it back to the pool. It's a fairly trivial concept. There were some limitations, though, if you've ever worked, for example, with PHP on Apache, it doesn't work with pools because it's not multi-threaded. So we actually have a solution for that, database resident connection pooling. Just does it on the database side. Same concept. Works quite well. So make sure you're pooling. Luckily, to implement this particular solution, it's fairly simple. We create a new module called pool. Bring in the driver here. Sorry, let me zoom in. We bring in the driver here. This time, we use the driver to create a pool with about 20 connections. And then we create an accessor, just get the pool and return out the pool when we need it. And the only code change here is that we get our pool and we get a connection from it. So rather than bringing the database driver itself, now I just bring in the pool module and I can pull right from that. So if you look at solution 1, at the very top, and we go to solution 2, the only change is the module we bring in, and then rather than get connection, we get the pool and get a connection from it. Pretty straightforward. So this time, we'll run test 2. Now it's going a lot better, right? In fact, we'll let it finish this time. Probably going to be about 11, not even, 10.5 seconds. Not bad. So 120 down to 10.5, and very little change in the code. It's pretty awesome. But we can do better, right? So in take 3, we're going to fix another thing that we're doing wrong in the code. You may have heard that joins are bad. And so what we have in this solution is kind of like a avoiding join example. That's actually a lot worse. Actually, relational database management systems are highly efficient at joining data. So the last thing you want to do is join in the client or application tiers. Big mistake. So instead, we're going to join in the database tier, and we're going to, in doing so, reduce the number of total queries from 7 down to 3, which also reduces total network traffic, right? The solution here does change a little bit. You see our query has grown. And it's because we're going to departments, but also joining in locations, joining in countries, employees, jobs, and so on. So with that change, now we're starting to fly. 4.2 seconds. Wait a second. How fast did we do it over here? Ooh. 3. Well, unfortunately, in this particular scenario, the winner of the Create JSON as Fast as You Can contest is, well, wait a second. Do you guys feel a little cheated, maybe? When you think about it, the solution I showed you in the very beginning, using the server-side code, it doesn't accurately compete with what we're doing here in Node, right? Because if, for example, I was creating the JSON from a schema and simply inserting that into another table in the same database, then that solution's amazing, right? You don't want to pull it out of the database into your middle tier or application tier and then massage it a bit and send it back into the database, right? We can do all that with a stored procedure. It's much more efficient. But in this particular scenario with Node, what I'm really doing is sort of like more of a RESTful API scenario, right? Where we got to pull it out of the database, and we're going to eventually send it off to a client somewhere. So we need to compare apples to apples. So in this next solution, actually this is the whole thing. It's just a few lines, 41 lines of code in Node, because remember, all the work is being done in the server. And now I'm using the connection to execute not a SQL query, but what we call an anonymous PL/SQL block. It's not named and stored. It's executed on the fly. And so I'm using it to invoke a stored procedure. And I get the result of that into this bind variable, but now you see I'm using a bind out, so I can get that JSON into Node. So if we run this one, 4.2 was our fastest with Node. All right. Node wins. Now, to be quite fair, I could have optimized the PL SQL solution a bit more. I'm not sure where that would have gone. But this is a Node talk, so you got to know when to stop, right? But I don't know when to stop. So I want to show you one final optimization. This is something pretty neat that in a language like PL SQL, it's not even a possibility. PL SQL is single-threaded, a lot like JavaScript. But unlike JavaScript, we don't have the ability to take I/O-based operations or heavy CPU-based operations and offload those to some background thread or process, right? I could probably work some magic to make it happen, but it's certainly not baked in like it is with Node. So I can re-architect the solution to do that. And this does change the organization of the code quite a bit. So what I'm doing here, in this function getDepartment, it's now the only function. We're not calling function after function after function. Instead, we use async parallel to fire off these, think of them as child functions, and run them in parallel, and do as much work as we can in parallel. So here's the second, here's the third, and finally, there's this last function, which will run when the other three have finished. And we can use this to do any last-second manipulation or massaging of the data we need before we just send that out to the client. So if we look at this one, and I've had mixed results with this. Really, I think it's a result of just not using a real setup where we have a separate server for both. There's truly no network latency here. But this one actually worked out. We got down to 3.6 seconds. So not too shabby, right? So that is all I have for you. For many apps, the relational model, transactions, ACID, all that, it's going to remain a very important part of application development. That doesn't mean we can't use Node. That doesn't mean we can't make the folks that need JSON data or just prefer it happy. Node can do this with ease, but it's important to learn about the database features and leverage them appropriately. It doesn't matter which database you're using, really, to make sure you get the best performance. Thank you.